For a type 2, you only have one check. For the type 1, the older type, the bypass goes through a similar backflow preventer. This is a double check detector assembly. This is the double check on the bypass. So I'm bypassing from before both checks and coming back in after both checks. So the meter is right here, double check is here. Testing for this would be the same as you would do for a normal double check detector. Here's test cock 1, test cock 2, and then you could test these just as you would a normal double check. On a type 2 bypass, water is flowing this way on this one because I've spun the unit around. The first exit of the water comes after the first check, which is right here. It goes through a bypass with a test cock, shut off, and goes through a single check, but it's only bypassing one check in the DC. So it has a shut off before and after and has test cocks on both of those. So I can test this check separately from testing this. I can have supply water pressure on this side and shut it off downstream, so I can test this check not only for positive seal, but also for the spring pressure. One of the things that make this more efficient is that you have a smaller spring in this one. Since I'm only trying to balance it to the 2 gallons per minute around one check, I can do this much closer in tolerance than I can with the older type using the double check. For this demonstration purposes, we have mocked up a unit with both a type 1 and a type 2 bypass on either side. So the type 1 with the standard double check and the type 2 with a single check. In reality, both are protecting in the same manner because I'm using the first check of the mainline unit as the first check of the bypass as well. So any readings that I take, if I take the reading across the first check, be it an RP or a DCDA, that reading can be used for both places on a testing form. This is type 2 with a single check here, a type 2 single check here. So I have 2 checks protecting the water supply. So the water supply is adequately protected the same way it was before. It does 2 things. One, as I said, I can keep this at a smaller tolerance, make this spring lower so that I can get my flow rates that are required so that I can measure up to 2 gallons per minute accurately. And it means I only have to test the first check on the mainline unit once, saving time for the tester and obviously saving some money on the bypasses. If this single check is fouled, just like it would be in any other situation, if this check is fouled and I had back pressure, the water could be forced past this, but it would be stopped by the first check of the mainline unit. If this were an RPDA with the relief valve on the bottom, if this first check were fouled, water going back would go into the zone, the reduced pressure zone. So it not only would be still protected if the number 1 check is working, but if this leaks by and pressure goes back into the zone pressure increases until the relief valve opening point is reached, and then water is dumped to the outside. So both on a DCDA and an RPDA, the testing would be the same and the results would be the same. On a typical testing form, you will have a serial number requirement for the mainline unit, and you'll have a serial number requirement for the bypass unit. On our units, there is a serial number on the mainline unit, and then a serial number on the bypass unit for the single check for the type 2. You will record the mainline units with this shut off as you normally would, check the double check as you would normally test it, record the values, record the value of the number 1 check, and if it's sealed tight against backflow for the number 2 check. The same thing, you can turn off that and turn the bypass on, test across here to check and make sure the testing of this check against back pressure. So if you're pressuring it and it shows positively that it's shut, everything is fine. You can also read the differential across this if that is required on your form. Some forms require the differential reading, some forms do not. They just want to make sure it's tight against backflow conditions. If it does, it passes the test. So you can see the testing of a type 2 will be shortened by not having to retest number 1 spring on the mainline unit. You're just using it as the first check of the bypass as well. And simply checking this check gives you then the complete readings that you need.